Hello, my name is Tonio, and I would like to give you a short introduction to our Wind4Birds online tool. Wind4Birds consists of two independent modules, the first one dealing with wind turbine dimensions and the second one with wind turbine locations. For this tutorial, I will focus on the first module. And here the idea is that you can compare scenarios where wind turbines with different dimensions are used for wind farm projects. And these could either be greenfield or repowering projects. And this comparison should help to identify the option which minimizes the collision risk of birds. Within the approach that we have applied for this module, the two most important wind turbine parameters are ground clearance and rotor diameter. When using the Wind4Birds wind turbine dimensions module, the first thing that you need to do is to select the study species. In this drop-down menu, you can either select one of the 6 raptor species which are integrated in the tool at the moment, or you can choose to use custom input data, which could be from any bird species. For this example, I am going to use the red kite as a study species. And you see that the first part of the user input, the bird data, is already pre-filled for this integrated species. So we can directly move to the second part, where the wind turbine characteristics need to be indicated for each scenario. So I'll start with the first scenario. I'll use 30 meters as a ground clearance and 100 meters as a rotor diameter. And you see that some more input parameters are already pre-filled now. This concerns, for example, the rotor rotation speed, blade width, and rated power. And the proposed values here are predictions based on the indicated rotor diameter. But if you have more specific information at hand concerning your wind farm project of interest, these default values can be overwritten at any time. I'll indicate 5 as the number of turbines for this scenario, and then we can move to the second scenario. I'll again use 100 meters as a rotor diameter, but I'll move the ground clearance from 30 meters to 80 meters. And now we have everything we need to launch the calculation for the first time. And you see the output figure appearing here on the right. The first 2 panels illustrate some of the input parameters, the flight height distribution, and the total power capacity for each of the scenarios. The third figure is the main results figure, indicating the total collision risk. And here you see that for the second scenario, the total collision risk is decreased by about 50% compared to the first scenario. And then there are a couple of additional panels indicating some derived output variables. And to illustrate these a bit better, I will add a third scenario. Here I'm going to use the same ground clearance as for the first scenario, but then a larger rotor diameter, 150 meters instead of 100 meters. And I'll again launch the calculation. And you see that now a third color has appeared for the third scenario. The total power capacity is substantially higher in this third scenario. The total collision risk is also higher for this third scenario. But when you now look at the collision risk per megawatt, this is actually quite a bit lower in the third scenario compared to the first. For more information about the Wind4Birds tool, I invite you to take a look at the user guide, which can be accessed through this button at the top right of the page. And for now, I would like to thank you for listening.